All right, so we're getting started with energy, talking about energy. This is our fourth unit, and I want to just first start off by looking at what we might already know about energy. So if we look at this image here, we've got a bicyclist sitting at the top of a hill, and they're poised to go down the hill. Excuse me. So we have 4 points along the hill. And we want to make the assumption that as the cyclist goes down the hill, that the bicyclist does not brake. So they are going to just kind of coast down the hill. So we have some questions here. All right. If the bicyclist is just coasting down the hill, that means they're not pedaling, they're not actively adding anything to their speed. Imagine they're, instead of a bicyclist, they're just like a ball rolling down the hill. At what point is the kinetic energy, that is the energy of motion of this object, the bicyclist, zero? All right, so where do they have zero motion? Okay, you might look at that and say, well, at the top of the hill here at point W, they would have no motion because they haven't started moving down the hill yet. And then at what point would their potential energy be zero? So this would be their ability to actually do something, right? A kinetic energy is kind of like the realization of the potential that this object has to do something. So at what point would they have zero potential to do anything else? All right. So up here at W, if here we have our zero kinetic energy, they aren't actually doing anything yet, then down here at point Z would be where the opposite's true. All of their energy has gone into doing something where they have no more energy that can potentially do something or that could become something. Now, let's think now bicyclist is actually pedaling. What form of energy is the bicyclist using to pedal? All right, so in the first A and B, we could think of a bicyclist as kind of just like as a ball rolling down the hill. But what do we think would happen? And what energy would the bicyclist be using to pedal? The pedals that will propel them forward. All right. So we're going to kind of get into these different forms of energy. And if you said chemical energy or food energy, that would be correct because you have to use energy, burn energy from the chemical reactions in your body that we fuel with the food that we eat in order to move our muscles. So that would be the form of energy that you would use to pedal a bicycle. All right, so we're talking about energy. So what is energy? All right, because I've already mentioned a couple of things about it, but let's just think of, okay, what is energy? So energy is something that can do things for us. So it's going to change something. All right, so energy is really strongly related to change. And an object can change the surroundings that they are in, or they can change themselves. And when that happens, these objects have energy. So either the surroundings will get changed by the object, or the object could get changed by the surroundings. So in physics, we talk about energy as the ability to do work or to produce change, because doing work is a way that we can see a change. Now, when we talk about doing work in physics, this isn't the same as you sitting and doing the work of like writing an essay, though there is physical work involved with that. But work in physics has a very specific definition that is related to forces acting on an object and the distance that that object is moved as a result of those forces. So when we say work, we're talking the quantity that results from a force moving an object a certain distance. And work is related to energy. So energy does work. All right. Now, we use energy in a bunch of different ways. All right. So we can use energy to produce light or heat. We can use energy to make things move, such as the bicyclist pedaling their bicycle. We can use energy to help us make sound. So things that slam into each other release energy and produce sound. Or listening to things through your headphones, that also produces sound. I am using energy to produce sound right now as my muscles are contracting and pushing air through my vocal folds, and that causes them to vibrate. And as they vibrate, they're doing work. We have the force of the air vibrating my vocal folds, which is producing sound. We can use energy to make things grow. All right, so using sunlight in terms of, say, photosynthesis, we use sunlight to create more parts of plants, and the plants grow by using sunlight through the process of photosynthesis. And we can also use energy to power technology. And we saw this when we looked at the Hubble and Webb telescope videos. They use energy to power the technology that they need in order to make the telescopes work. Now, so we can use energy in a whole lot of different ways. So how can we do that if we are just using this thing called energy? Well, the reason we can use energy in all these different ways is because energy comes in a bunch of different forms. So when we have different forms of energy, we can use that energy to create different types of results. All right, so just to kind of recap, energy is known by the changes it causes. All right, so we can detect energy by seeing an effect that is a change in either an object or the surroundings of that object. One way we can detect energy is by observing if work is done on an object or by an object, by looking to see, does this have a force that moves an object a distance? All right. So energy is going to be transferred from an object to the surroundings, or from the surroundings to the object, or from one object to another, by having that force move that object through a distance. So we can transfer energy either from one location to another or from one form to another by doing work. In physics, this is called the work energy theorem, and it says that work is the change in energy of a system. Now, work and energy, because they are so tightly related, are actually measured with the same unit, and that unit is the SI unit of joules. It's named after a guy who did a lot of work with energy, and joules are going to be represented with a capital J. All right. And the two types of energy we've already mentioned in that slide, the first slide, are potential energy and kinetic energy. All right. So these are also two sorts of major topics, like major divisions of the different types of energy. We can have potential energy, that is going to be the energy of possibility. It's often based on position. So we can think of the bicyclist at the top of the hill compared to being at the bottom of the hill. That bicyclist at the top of the hill has energy because of the position of that bike at the top of the hill. But we can also have different kinds of potential energy that are related to the state that the material or the object has. So we can have things like nuclear potential energy, where we have an unstable nucleus that's waiting to undergo radioactive decay or nuclear fission. We can have chemical potential energy, where you have chemical bonds that are stored with a lot of energy in them, and then as they get broken, they release that energy. The other general type of energy is called kinetic energy, and this is the energy of motion. So it's going to be dealing with how things move. And specifically, we're going to look at how things move in terms of the velocity they have compared to their mass. All right, so kinetic energy is going to be dependent on mass and velocity. And we often think of kinetic energy in terms of moving an object, like the bicyclist moving down the hill. But kinetic energy can also be described as different types of energy that relate to the motion of particles or waves, like electromagnetic waves or heat radiation. All right. So we're going to get more into this forms of energy in the next video and look at the different types. All right.